Let's see what is the force acting on a curved plate. In the curved plate, there are two conditions. One is the jet is striking at the center. The jet is striking at the center of the curved plate, and another case is jet is striking tangentially to the blade. So this is the curved plate, and this is velocity v with which it is impacting this curved plate. The fluid splits in this way tangentially to this plate. So I am considering this as a symmetrical plate. If this is a symmetrical plate, outlet blade angle and inlet blade angle both will be same. I am considering it as theta. So this is inlet blade angle, inlet plate angle or blade angle, inlet blade angle, and this is outlet blade angle. So if this is the velocity v, what will be the velocity? Here also there is v, here there is v, and it has two components of velocity. If this is theta, this is exiting tangentially, so this will be also theta. So tangent to this will be parallel to this, so that will be theta, and this is v cos theta, this is v sin theta. And here also, if this is theta to horizontal, so this will be theta. This is v cos theta, this is v sin theta. So now the force is equal to, this is x direction, so fx and fy. So what is fx? Balancing the forces in the direction of x. So there will be m dot v1 minus m dot v2. This is the momentum equation that we have seen. So mass flow rate is equal to rho av. This is the cross sectional area of the jet. So rho av with what velocity it is touching this is v. So rho av into v1 minus v2. v1 is v and v2 minus v2 is this v cos theta, v cos theta. So minus v cos theta, since the direction of velocity is initial velocity is this one, and when it is returning it is opposite to the direction of initial velocity, so that is minus. So rho av into, taking v common, v into 1 plus cos theta. So rho av square into 1 plus cos theta. This is the fx. So then what is fy? M dot v1 minus m dot v2. The vertical velocity at inlet, there is only horizontal velocity, so there is no vertical velocity. M dot into 0 minus v2. What is v2? One is v sin theta. So this both gets balanced, and that will be 0. V sin theta upside and v sin theta downside. So now fy is equal to 0. So this is how you need to analyze a fixed plate at the when jet is striking the fixed curved plate at center. Sometimes angle of deflection will be given. Angle of deflection of jet. What is angle of deflection of jet is? So if it is entering this way, if it is leaving this way, so this is theta, and this is theta, this is also theta. So angle of deflection of jet is this one, 180 minus theta. This is angle of deflection of jet, which is equal to 180 minus theta. So sometimes in the question the data will be given in the terms of angle of deflection of jet, and sometimes it will be given in blade angle. So you need to confirm that which angle is given in the question. Angle of deflection is given, then we need to consider this equation 180 minus theta. So now let us see the fixed plate, the curved fixed plate condition when the jet is entering tangentially at one end. So let us see symmetrical case and unsymmetrical case. Unsymmetrical. And this is symmetrical case. Now this, let us see the first unsymmetrical case. With V, it is entering here, and as it is entering tangentially, first we need to understand what is unsymmetrical. Unsymmetrical means the inlet angle and outlet angle are different. So this is let me say this is phi, and this is theta. So phi is outlet blade angle and theta is inlet blade angle. If it is entering tangentially, so this will be theta and this will be V cos theta, and in vertical direction it is V sin theta. So if it is leaving in this way, this is V, this is phi, this is V cos phi, and this is V sin phi. So now analyzing this, forces will be in x and y direction. So Fx is equal to m dot v1 minus m dot v2. The force exerted by this, the resistance exerted by the plate. So that will be rho AV. This is the m dot with velocity v. It is striking this, so it is rho AV into v1 minus v2. So rho AV into v1 in x direction. What is entering velocity? That is v cos theta. V cos theta minus what is v2? The x component of leaving velocity, that is v cos phi. So minus v cos phi, since the direction is opposite to the inlet one. So rho a v square cos theta, taking v cos theta common, and this is cos theta and this is cos phi. So taking v common, cos theta minus into minus plus cos phi. So this is the Fx. So what is Fy? Fy is equal to rho AV, this is the mass flow rate, and V1. V1 is V sin theta. So V sin theta, and the leaving velocity is V sin phi minus V sin phi, since both are in same direction. So there will be no minus sign for this. So taking V outside, rho a V square into sin theta minus sin phi. So next, these are the forces that will be acting if the plate is unsymmetrical. If it is symmetrical, so if it is symmetrical, So this is theta only, this is theta. If theta is equal to phi, then it is called as symmetrical. Inlet blade angle and outlet blade angle both will be same, and this is V, this will be, this is theta, this is V cos theta, and this is V sin theta, and here also here, looking this at this point, this is V, this is theta, this is V cos theta, this is V sin theta. So now analyzing this, fx is equal to m dot v1 minus m dot v2. So what is m dot rho a v? With velocity v, it is striking. And what is v1? In x direction, it is v cos theta, minus in x direction the exit velocity is v cos theta, but in opposite direction, so include minus v cos theta. So rho a v square cos theta, taking cos theta common, v and cos theta common, so 1 plus 1. So 2 rho a v square cos theta. So this is fx. So what about fy? Fy is equal to rho av into v1. What is entering velocity? V sin theta. V sin theta minus the leaving velocity also v sin theta. So rho a v into v sin theta minus v sin theta, that is equal to 0, which is 0. Fy is equal to 0. So this is how you need to analyze when it is entering, when it is striking at center, and when it is striking in a tangential direction.